In this video, we continue our Databricks Optimize and Vacuum series, Part 2. If you're learning Databricks and want to understand how to improve Delta Lake performance and manage storage efficiently, this series is for you. In the previous part, we discussed how Optimize helps solve the small file problem by compacting many small files into fewer, larger files. In this part, we'll continue exploring Optimize and Vacuum and understand how these operations work together to improve performance and manage old files in your Delta tables. Remember, Optimize is primarily about performance. It reorganizes and compacts data files so that queries can read data more efficiently, benefit from better data skipping, and handle fewer files. On the other hand, Vacuum is primarily about storage cleanup. When data is updated or deleted in a Delta table, the old files are not immediately removed. They can remain available for a period of time to support features such as time travel and recovery. Vacuum removes old, unneeded data files that are outside the configured retention period. So, a simple way to remember this is Optimize improves query performance, Vacuum helps reclaim storage, and together they are important tools for maintaining healthy and efficient Delta Lake tables in Databricks.
Now let's understand how Optimize improves query performance in a Delta table. Before Optimize, the table may contain around 10,000 small files, with each file typically around 1 to 10 megabytes. This creates high file listing overhead because the engine has to manage and list a very large number of files. It also leads to poor data skipping because statistics are spread across many different files. As a result, queries may perform slow sequential scans, while the system also experiences high task scheduling overhead. Now, after running Optimize, those thousands of small files can be compacted into roughly 100 larger files, with each file around 1 gigabyte. This provides minimal file listing overhead, more effective min and max statistics per file, and therefore better data skipping. The result is faster sequential reads, along with fewer tasks and less pressure on the scheduler. And with modern Databricks, liquid clustering is recommended over Z-order. You can enable automatic liquid clustering by letting Databricks choose the optimal clustering keys. For example, alter table catalog.schema.tablename cluster by auto, then run optimize catalog.schema.tablename. So, in summary, Optimize reduces the small file problem, improves data skipping, reduces task overhead, and ultimately delivers faster query performance.
Now let's compare managed tables versus external tables in Databricks Unity Catalog and understand how maintenance differs between the two. Starting with managed tables. Managed tables provide several automated optimization capabilities. First, predictive optimization can automatically run Optimize, Vacuum, and Analyze based on actual usage patterns. Second, auto-compaction automatically combines small files after writes, helping reduce the small file problem. Third, optimized writes are enabled by default and help produce better-sized data files during writes. And finally, manual maintenance becomes optional because predictive optimization can handle these operations automatically. You can enable predictive optimization at the catalog level using alter catalog, your catalog, set DB properties, enable predictive optimization equals true. You can also enable it at the table level using alter table catalog.schema.tablename, set TBL properties, enable predictive optimization equals true. The image also highlights an important point. Predictive optimization is enabled by default for accounts created after November 11, 2024, while existing accounts are being rolled out gradually. Now let's look at external tables. Here, predictive optimization is not available. Auto-compaction is not automatically provided, so it must be manually configured, and manual maintenance is required. You need to schedule your own Optimize and Vacuum operations. For external tables, a scheduled job should run maintenance commands such as optimize catalog.schema.external then vacuum catalog.schema.external and also analyze table catalog.schema.external compute statistics for all columns. So the key takeaway is this. With managed tables, Databricks can automate much of the optimization and maintenance. With external tables, you have more responsibility for scheduling and managing these maintenance operations yourself. Therefore, when choosing between managed and external tables, consider not only where your data is stored, but also how much maintenance and optimization you want Databricks to manage automatically. Now, let's look at the recommended frequency for the most important Delta Lake maintenance operations. We'll compare managed tables with predictive optimization against external tables, where maintenance is handled manually. First is Optimize. For managed tables with predictive optimization, Optimize is automatic, so no manual action is needed. For external tables or manually managed tables, run Optimize daily or after large batch writes. As a best practice, run Optimize daily during off-peak hours for tables that receive frequent writes. Next is Vacuum. For managed tables with predictive optimization, Vacuum is also automatic, so no manual action is required. For external tables, run Vacuum daily if the retention period is 7 days. The manual scheduling best practice is to run Vacuum daily when using the default 7-day retention. Third is Analyze. Again, for managed tables with predictive optimization, Analyze is automatic, requiring no manual action. For external tables, run Analyze weekly or after schema changes. There are also some important best practices for streaming tables. For streaming workloads, use trigger intervals of 120 seconds or more. This helps reduce the creation of small files, which can otherwise affect performance and increase maintenance requirements. For large tables, another useful practice is to use partition predicates with Optimize. This allows you to optimize only the recent data instead of processing the entire table, which can make maintenance more efficient. So, the key frequency recommendations are, for managed tables with predictive optimization, Optimize, Vacuum, and Analyze are all automatic, meaning no manual action is needed. For external or manually managed tables, run Optimize daily or after large batch writes, Vacuum daily when using 7-day retention, and Analyze weekly or after schema changes. For frequent write tables, schedule Optimize during off-peak hours. For streaming tables, use trigger intervals of 120 seconds or more to reduce small files. And for large tables, use partition predicates so Optimize focuses only on recent data. Following these frequencies helps keep your Delta Lake tables optimized while minimizing unnecessary manual maintenance. Now let's move on to retention period settings. Understanding retention is important because it determines how long deleted data files and transaction log history are preserved, and it directly affects your ability to use features such as time travel. Default retention periods. Let's start with the default retention periods. The first property is delta.deleted file retention duration. Its default value is 7 days. This controls how long Vacuum keeps unreferenced data files. The second property is delta.log retention duration. Its default value is 30 days. This controls how long the transaction log history is preserved. Increasing data file retention. If you need a longer retention period, you can configure it at the table level. For example, to increase data file retention to 30 days, which enables 30-day time travel, use the following command: alter table catalog.schema.tablename, set TBL properties equals delta.deleted file retention duration equals 30 days. This changes the deleted file retention duration from the default 7 days to 30 days. Increasing log retention. You can also increase the transaction log retention.
For example, to increase log retention to 90 days, use alter table catalog.schema.tablename set TBL properties equals delta.log retention duration equals 90 days. This allows the transaction log history to be preserved for the specified 90-day period. Checking current settings. After making these changes, you can check the current table properties using show TBL properties catalog.schema.tablename. This allows you to verify the retention settings currently configured for the table. Important rule number 1. Now, there are several important rules to remember. First, log retention duration must be greater than or equal to deleted file retention duration. So the transaction log retention period cannot be shorter than the data file retention period. Important rule number 2. Second, increasing retention comes with a cost. A longer retention period means higher storage costs because more old files are kept for a longer period of time. Important rule number 3, 30-day time travel. Third, if your goal is to enable 30-day time travel, you need to set both properties to at least 30 days. That means the deleted file retention duration and the transaction log retention duration must both be configured for 30 days or longer. And finally, set your retention period before enabling predictive optimization. This is especially important because Vacuum uses deleted file retention duration when determining which unreferenced files can be removed. Closing summary. So, to summarize, the default deleted file retention is 7 days, while the default transaction log retention is 30 days. You can increase these values using cable-level TBL properties. Use show TBL properties to check the current settings. Remember that log retention duration must be greater than or equal to deleted file retention duration. Increasing retention means higher storage costs. To enable 30-day time travel, set both retention properties to at least 30 days. And most importantly, configure your desired retention before enabling predictive optimization, because Vacuum relies on deleted file retention duration. With these settings configured correctly, you can balance time travel requirements, data protection, and storage costs effectively.
Now let's wrap everything up with a quick summary of the key recommendations. If you're working with Databricks and want better table performance, easier maintenance, and more efficient SQL workloads, here are the main recommendations to keep in mind. First, use Unity Catalog Managed Tables whenever possible. The recommended action is to get predictive optimization for free. This helps automate important table maintenance tasks and reduces the amount of manual optimization you need to perform. Second, enable predictive optimization. One of its biggest advantages is that it eliminates the need to manually schedule, optimize, and vacuum operations. Instead of managing these maintenance tasks yourself, predictive optimization can handle them automatically. Third, use liquid clustering, also known as cluster by auto. Liquid clustering is recommended because it can be better than traditional Z-order in many scenarios. More importantly, it can adapt to changing query patterns, helping your tables stay optimized as the way you query your data changes. Fourth, set your retention period before enabling predictive optimization. This is important because it helps you avoid accidentally losing the ability to travel back through your table history. In other words, configure your desired retention first and then enable predictive optimization. Fifth, when you're working with external tables, schedule daily maintenance jobs. These jobs should include optimize, vacuum, and analyze. Unlike managed tables where predictive optimization can automate maintenance, external tables may require you to schedule these operations yourself. Sixth, remember that the default retention of 7 days is fine for most use cases. You generally don't need to increase the retention period unless your organization's compliance or audit requirements specifically require a longer period. And finally, consider using DB-SQL serverless. It gives you the latest runtime, photon, and caching automatically, helping you take advantage of the latest capabilities without having to manage the underlying infrastructure yourself. So, to summarize, use Unity Catalog Managed Tables and take advantage of free predictive optimization.
Enable predictive optimization to eliminate manual optimize and vacuum scheduling. Use liquid clustering or cluster by auto instead of relying solely on Z-order, especially when query patterns change. Set your retention period before enabling predictive optimization. For external tables, schedule daily optimize, vacuum, and analyze jobs. Keep the default 7-day retention unless compliance or auditing requires more. And finally, use DB-SQL serverless to get the latest runtime, photon, and automatic caching. Those are the key recommendations to keep your Databricks environment optimized, automated, and easier to maintain.